Nuclear Fallout Levels, Fukushima Daiichi Power Plant, by Alyssa Peterson, Michaela Marcos, Gontre Azadeh, and Iris Young. It was March 11, 2011, when the Tohoku earthquake and subsequent tsunami hit the islands of Japan. The Fukushima Daiichi nuclear power plant was on the island of Honshu when, in the days following the earthquake and tsunami, this nuclear power plant had a nuclear meltdown, and radioactive isotopes were released into the environment. Ever since the Chernobyl disaster of 1987, the world has been highly concerned that radioactive isotopes, such as the ones released at Chernobyl and Fukushima, will cause bodily harm to humans. However, U.S. studies from as recent as February 2012 show that we in the United States have nothing to worry about. Immediately after the Fukushima Daiichi meltdown, there was a release of radioactive isotopes into the atmosphere. In the form of gases and small liquid and solid particles, the radioactive elements were able to travel vast distances across oceans and landmass and were detected in the United States. This can be seen in the map, which shows the deposition of the isotope cesium-137 from Japan to the United States over a large body of water. The nuclear fallout, or the amount of the radioactive isotopes in the atmosphere following a nuclear blast, were detected by analyzing environmental samples from around the world. From observing nuclear fallout, scientists estimate that it took the radioactive particles 18 days to circle the Earth. This means that before 18 days, the radioactive particles were already in the United States. According to the nuclear fallout map, this can be approximated to about 10 days before radioactive particles actually hit in the United States.
The USGS is the United States Geological Survey. They are a department within the NADP, or the National Atmospheric Deposition Program. The USGS, working with the U.S. Environmental Protection Agency, or EPA, led the study to detect the levels of nuclear fallout in the United States. Both programs conducted different experiments, but the results were reported together in order to paint a better picture of nuclear fallout in the United States.
Using RadNet, a software that monitors radioactivity, the USGS tested the amount of nuclear fallout at NADP sites across the United States. The NADP sites can be seen in the far left column. Of the various NADP sites, only about 20% of the sites detected traces of radioactive isotopes, iodine-131, cesium-134, and cesium-137. Those numbers can be seen in the three columns to the right. In this graph, you can also see the coordinates of all of these NADP sites, and also the periods in which samples were taken. The test sites varied from major cities to rural areas, so that the test sites gave an accurate picture of the United States as a whole. The RadNet software was used to detect and calculate the amount of isotopes over the course of 2 weeks, and each isotope was measured separately with regard to its precipitation. This means the isotopes were detected according to its presence in the rain collected over 2 weeks.
From March 15, 2011, the day after the nuclear meltdown, to April 8, 2011, the EPA used radiation-detecting software to measure the amounts of iodine-131, cesium-134, and cesium-137 in precipitation. And this year, the USGS used RadNet at NADP sites to determine if there was still nuclear fallout in the U.S. The data found by the EPA and the data found by the USGS both show that all the isotopes were found between 0.7 to 5100 becquerel per square meter. A becquerel is the SI unit of radioactivity. It is a measure in which one nucleus of a radioactive material decays per second.
Now, 5,100 becquerels may seem like a lot of radiation, but this is simply not the case. An average adult human has a radiation of 7,000 becquerels. This shows that the radiation from the Fukushima Daiichi nuclear power plant in Japan is not a threat to human life in the United States. The isotopes that traveled across land and ocean are not dangerous enough to harm us.